So this is lesson 1.5. It is about solving absolute value equations. So hopefully after you watch this, that will be something you'll be able to do. Now, most Algebra 1 teachers will go over this, so this shouldn't be new. This should be something of a review. So let's get going. So remember, the absolute value is the number of units that a particular number is from 0 on the number line. The number of units that a number is from 0 on the number line. So if we look at a number line, let's look first at an a value that is greater than or equal to 0. Let's pick 3. Well, if we're at 3, then we are 3 units away from 0. The absolute value of 3 is 3. So that's why this first line says that the absolute value of a is a when a is greater than or equal to 0. So think positives or 0, the absolute value doesn't really change anything. Now, if we're in the negative region, like -2, we are 2 units away from 0, so the absolute value of -2 is 2. So what did we do? Well, we had to change the sign. So that's why the second one says if a is less than 0, then the absolute value of a equals -a. So let's look at an example. So we're just going to evaluate these. Now you want to evaluate what's inside the absolute value. So let's look at the first one. Think about if we're at -6. How many units away from 0 are we? We're 6 units away, so the absolute value of -6 is 6. So see how it became the opposite. Now for part B, we want to take the answer inside of the parentheses, that absolute value. So the inside, -4 plus 2 is -2. We're going to take the absolute value of that, so it becomes 2. So let's depict that on a number line. Give me a second, I need to erase this. That's not quite in the right spot. Give me a second, I'll erase it. Okay. So let's start at -4. And if we're in the negative direction, -4, and we move 2 to the right, so we're going to start at -4. We're going to go 2 units to the right, and now you'll see we've landed at -2. And how many units are we from 0? We're 2 units from 0, so that's why the answer is 2. Now let's take a look at part C. For part C, you want to get an answer for the stuff inside. So ignore the absolute value brackets and the negative, and let's get a singular number inside. So 5 plus -4 squared, -2 squared is going to become 4. So it's 5 plus 4 minus 7, which is going to be 9 minus 7, which is 2. Now the absolute value that's on that 2 is not going to change the 2, and so then that negative out in front just tacks onto it because there's nothing to change it, and so it becomes -2. So if there's an absolute value with a negative in front, just leave it, leave it, leave it till the end. Let's take a look at how we could write an expression for the absolute value of x plus 2. Now, if you continue to study math and you study absolute values in like a pre-calc class or in a calculus class, you will see what's called a piecewise function for an absolute value. What we're going to do is we're going to look at two cases. The first case is our positive case. That's when the absolute value of x plus 2 is just going to stay x plus 2. Our positive case, remember, our positive absolute value doesn't change. But now we have the negative case, which I'm going to call case 2. Now, case 1, see how we could take this x plus 2 and rearrange it and solve it? So that case applies for any x is greater than or equal to negative 2. Now let's look at case 2. Case 2 is when x plus 2 is less than 0, a negative. If you actually solve that, move the positive 2 to the other side, it becomes a negative 2. So this case is the opposite of x plus 2, and we write that by putting a negative out in front. So we really have two cases. For all x is greater than or equal to negative 2, it becomes x plus 1. For all x is less than negative 2, it becomes the opposite, negative of x plus 2. Let's look at example 3. So if you have an absolute value equation, we're going to have two cases, the positive case and the negative case. The positive case is when x plus 6 doesn't change and it's just equal to 9. So that's where x plus 6 equals 9. So that's your positive case. We don't have to change it. And now you just subtract 6 from both sides and you can solve it. So we get that x is equal to 3. Now let's do the second case, the negative case. The negative case is where x plus 6 is less than 0. So what does that mean? Well, that means it has to flip signs. So it has to be the opposite of x plus 6. So we're going to put a negative out in front. And that's what we're going to solve this time. The opposite of x plus 6 equals 9. And so we get negative x minus 6. Distribute that negative. Add 6 to both sides. We get negative x equals 15. And then divide by negative 1. And we get x equals negative 15. Well, I'll put the negative here in a second. Sorry about that. And if you put those back into the original, 3 plus 6 is 9. The absolute value of that is 9. Negative 15 plus 6 is negative 9. The absolute value of that is 9. So you should be able to plug those back into the original, and they should work for both cases. So if we look at how to write the answer, we have two solutions, 3 or negative 15. Now, here we have to think about what the absolute value means. Here it says the absolute value of x plus 1 equals a negative number. If we try the cases, will x plus 1, let's just kind of pretend like we just jumped in and started the cases. If we solve x plus 1 equals negative 4, you get negative 5. Now, think about if you actually go ahead and check it. You see up in the top here, negative 5 plus 1 is negative 4. The absolute value of that is 4, not negative 4. They wanted us to get an answer of negative 4. No matter what we do, we're never, ever going to get a negative answer. So, anytime you see that the absolute value equals a negative number, we can immediately just jump to the conclusion and say, there's no solution. Now, if you want to write that null set symbol, which is like a kind of like a 0 with a slash through it, you can do that. But you don't have to set up the two cases because there's no way that a negative will ever equal an absolute value. Now, in this example, we have an x on the inside and an x on the outside of our absolute values. We're still going to set up the two cases, and we're going to solve it the way that we did the other ones, okay? So let's set up our two cases. In order to make sure that our answers work, anytime the x is inside and outside for these ones, please check, you must check them back in the original. So yes, we're still going to have two cases, but we're going to have to check them. Now our first case is our positive case. That's just what you see, take off the absolute value. So x plus 6 equals 2x. So we're going to subtract x from both sides, and then we get that x is equal to 6. Now let's look at our negative case. That's case 2. Case 2, first let's check it. So if we put it back in the original, we get 12 equals 12, which is perfectly good. Case 1 worked. Now let's do case 2. That's our negative case. So that is when the opposite of x plus 6 equals 2x. So negative x plus 6 equals 2x. So let's distribute the negative. And now let's solve. So let's add x to both sides. We get negative 6 equals 3x. Divide both sides by 3. We get x equals negative 2. Now before we decide if that one wants to work, let's go ahead and plug it back into the original. I shouldn't really necessarily circle it yet, but we'll get to that. So if you put it in, we get the absolute value of negative, or 4 is equal to negative 4. So it doesn't work. So we should cross that one out. So our only answer is x equals 6. So you must check these. If you have x's on the inside and outside of your absolute value, it's always a good idea to check them because sometimes they work and sometimes they do not. Let's look at example 6. Now, before you do these, the ones before, we didn't have to do this, but we have this plus 5 here. So you must move the 5 by subtraction and isolate the absolute value. So we get the absolute value of 2x plus 7 equals negative 5. Since we got that the absolute value is equal to a negative, we can immediately stop because no matter what, our cases won't work. And so the answer to this would be no solution. Now, if you wanted to actually do the two cases, when you went and stuck them back in and checked them, they wouldn't work. Now let's take a look at this one. This is just an expression we're going to evaluate. So we're going to take out the x value and we're going to replace it with negative 5. Again, we want to get a singular value inside of our absolute value before you do the absolute value. So I've taken out the x and I've replaced it with the value they told me, negative 5. So now let's just follow order of operations. So we're going to multiply the 3 and the negative 5 to get negative 15. We're going to get negative 17 inside our absolute values, which becomes a positive 17. 17 plus 4 is 21. Done. You can't go further. There's nothing else for us to do or solve. So just stick the value in and simplify it as much as you can. So there's example 7. Here's example 8. Now this is one of the most difficult types because again we have x's inside and out, so these are the kind that we must check. Let's set up our two cases. Case 1 is where the x minus 2 as is equals 2x minus 10. Then start moving things around, so let's move the x's to the right. Then let's add 10 to both sides. So basic equation stuff. We get x equals 8. Now let's take a minute and shove 8 into our original equation to make sure that nothing funky happened. So let's check it. So I get the absolute value of 6 equals 6, so it works perfectly. Now let's set up case 2. Now we have the opposite of x minus 2 equals 2x minus 10. Distribute the negative. Move around the x's so that we can solve. So let's add x to both sides. We get 2 equals 3x minus 10. Now let's add 10 to both sides. We get 3x equals 12. Divide off the 3. We get x equals 4. Now let's check it. Back in the original problem. So we get the absolute value of 4 minus 2, which is 2. On the right side, we get 8 minus 10, which is negative 2. So those are not the same. So cross that one out. 4 is not your answer. Okay? The assignment that I gave you is what you want to do in Google Classroom. Please just do all the problems that are there. I'm going to be putting all of your stuff in Google Classroom. So if in the note sheet it says one thing, just check out Google Classroom for your assignments, okay? So there is lesson 1.5. Thanks so much for watching, and you have a good day.